Alright guys, now I'm going to show you all the proof for the law of cosines. This one is, if you looked at the previous video for the law of sines, the law of cosines is a little bit more difficult. It's going to take some more oomph to get through it. I would stress here, like I did in class, that you really want to try to understand what I'm doing. Don't just memorize steps. I mean, you can memorize steps and you could spit it back out on a test, but that's not really helping you out. And I think if you put more effort up front and understand what I'm talking about, there's not really much to memorize. There's really not much to actually do once you get the basics down. Okay, once you understand what's going on, you're like, oh, it just follows from that. I'm just foiling. I'm just subtracting. Blah 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 blah. Okay, so this is what you're going to be given. You're going to be given this triangle here. You're also going to be given the first step: y squared plus k squared equals a squared. Now, following what I've said, you need to try to understand where does y squared plus k squared equals a squared come from? And there's a reason why I'm zooming in on this section here, and that's because that is this right triangle. And what famous theorem do we use that uses this? It's a Pythagorean theorem. Hopefully you were saying that. Pythagorean theorem. So that's what we did. We just Pythagored it up. So we got y squared plus k squared equals a squared. And what I'm going to do is I'm going to write the proof out down here. So I'm going to rewrite it here. If I'm going to do this, I don't have too much space, so I'm going to have to not write too big. All right, there we go. The next step is this entire length is C. In fact, maybe I should clearly label that this entire length is C. And if this entire length is C, and this piece here, this right here, is X, and this little piece here is K, then I can follow with an argument saying C minus X is K. Okay? In other words, this entire length is C. If I subtract out X, all I'm left with is K. Another way to look at this, X plus K, write this up here, X plus K is C. Hopefully that's clear. This length plus this length is this entire length. And so, if I subtract X from both sides, K is C minus X. Okay? A third way, if you're still looking at this like, why is this man speaking mumbo jumbo? Okay, a third way of looking at this is to realize that from a more concrete example, that if this is 0 and this is 10, and I say that this piece here is 2, then what is this length here? Well, I think it's pretty clear that you're going to say 10 minus 2 is 8. I think that's intuitive. Well, that's exactly what we did here, right? We said this is 10, this is 2, clearly not drawn on the scale. So 10 minus 2 is 8. Okay? So if you ever get stuck with what the heck we're doing when we're talking about with letters, or more, if you want to sound fancier, variables, what you always want to do is play with the concrete. It leads you to the abstract. Okay. Now, why am I spending so much time talking about C minus X is K? Well, if I have K here, I can replace it with C minus X. So I'm going to go ahead and do that. C minus X squared equals A squared plus Y squared. I recommend singing when you do math. It makes it funner. Okay. Next thing. What are we going to do? Well, I'm going to replace Y and X. And the question is what I'm going to replace Y and X with. So hopefully you said, aha, I'm going to do sine A, because sine A, I'm going to do it over here, sine A is equal to what? Sine A is equal to opposite over hypotenuse. So y over b. This is also why we spent some time going over the law of sines, because this technique was used first in the law of sines. So maybe if you have not watched the law of sines video, maybe you go through that and you watch it. Plus, I spent about 2 minutes going through and philosophizing about why proofs are important, and that's awesome. Okay, so b sine A is y. Okay. Following a similar argument, I can say cosine A is what? Cosine A is what? Cosine A is adjacent over hypotenuse. So x over b. Yep, x over b. Then I'm going to simplify. Multiply both sides by b. Bam, slice. b cosine a is x. So why do I care that b cosine a is x and b sine a is y? Well, if you remember, we're going to replace y and x with b sine a and x cosine b. I'm sorry, b cosine a and b sine a. So doing so, we get b sine a squared plus c minus b cosine a quantity squared equals a squared. Now what do we do? All right, so here's where things get interesting, okay? And you got to go back to Algebra 1, and you got to think to yourself, what does it mean when I square something? What does it mean when we say, and I'll put it right here, so I write math all over the place. What does it mean when I say 3 squared? That means 3 times 3. What does it mean when I say x squared? X times x. What does it mean when I say Anderson squared? Not funny, but I have to finish the joke anyways. Anderson times Anderson. Okay, so then b sine a is nothing more than b sine a times b sine a. And c minus b cosine a is nothing more than c minus b cosine a times c minus b cosine a. Fantastic. Okay, now comes the interesting part. What happens when you do b sine a times b sine a? Well, b times b is what? B squared. Sine a times sine a is what? Sine squared a. Remember, anything times anything is what? 3 times 3 is 3 squared, right? So the same argument is b times b is b squared. Okay. Also, you didn't have to do this if you didn't want to. I'm just trying to make it as clear as possible. You could have just b squared sine squared a. Right? We said the rule when you raise a power to a power is you multiply. So this is one. This is technically you have a little one here, a little one here. So 2 times 1 is 2. 1 times 2 again is 2. Okay. Hopefully that's clear. Moving on. This is the fun part. Whee! Fun part. Yeah, get the foil. Woo! Okay, so now we're going to foil. So c times c is c squared. Hopefully you see that. c times negative b cosine a is negative bc cosine a. Negative b cosine a times c is negative bc cosine a. By the way, traditionally we write it as BC. If you had written it as CB, it's not actually wrong. We just usually go in alphabetical order. It just makes it a little clearer. Negative b cosine a times negative b cosine a is positive because negative times negative is a positive. And b cosine a times b cosine a is b squared cosine squared a. And all that's equal to a squared. All right. That actually was the toughest part. Okay. By the way, I am actually going to flip over to another page. One thing that you can do is if you're given c minus b cosine a times c minus b cosine a, and if you look at this and you don't like this, you can actually do this via the box method. Okay. So if you get foiling, you can just watch this because it's fun to watch my hand move all over the place. But if you were watching me foil and you're like, how do you do that? Then follow this and this will probably make more sense. Okay, so, that's not there. Sorry. So what you do when you do the box is just a way of organizing it. So c times c is what? C squared. C times negative b cosine a is negative bc cosine a. By the way, note that this does not say bcc, it's bc cosine a. Same thing down here. Negative bc cosine a. And the last part is positive. Negative times negative is a positive. B times b squared. Cosine a times cosine a, cosine squared a. All right. Another note to make is some people were saying, why do I square cosine, but I don't square a? Keep in mind that cosine squared a means cosine A quantity squared. Okay? In other words, you're not doing cosine times A. When I see cosine A, I'm not doing cosine times A. It's this quantity together. In fact, there is no such thing as just cosine. It's cosine of something. It can't just be cosine. Okay? All right. Hopefully that's clear. So anyways, when you put this all together, you're right back here. So notice c squared minus bc cosine, bc cosine A minus bc cosine A. That's this business. And last part, b squared cosine squared, b squared cosine squared. So if doing this helps you, go for it. If it doesn't help you, then just FOIL like normal. Jeez, I don't know. All right, so moving on. B squared sine squared A plus c squared. Now what I can do here is I can put these two together. So it's like saying you have -1 of something and a -1 of something else. So -1 is -2. So -2 bc cosine A plus b squared cosine squared A equals A squared. All right, we're actually almost there. I know this looks crazy, but we are almost done. The next step that we have to do is you have b squared sine squared, b squared cosine squared. We're going to put these two together. So there's this rule in math called the commutative rule, which allows you to switch things up. What I'm essentially saying here is that if I give you 2 plus 3 plus 4 plus 5, if I want to, I can say 2 plus 5 plus 3 plus 4, right? These are equivalent, okay? It's called the commutative rule of addition, all right? So we're going to use the commutative rule of addition. I want to give you the fancy names for these so that you can impress your friends at your math parties, which I know you guys are still going to. So this becomes b squared sine squared A plus b squared cosine squared A plus c squared minus 2bc cosine A equals A squared. Saying all that, if somebody was walking by and you were watching this video and I was saying all that, they're probably like, oh my goodness, what does he do it? And then you realize it's actually really easy, but you're not telling anybody because you want to sound really smart. I know, I do that all the time. Okay, so the next thing is that if I have b squared sine squared plus b squared cosine squared, since I have a b squared here and here, I'm going to factor the b squared out. And just rewrite the rest of it. Okay. Now, what did I do here? Okay, what is factoring? Factoring is a math way of saying reverse distribution. So notice that if I distributed b squared times sine squared, I got b squared sine squared, and b squared times cosine squared is b squared cosine squared. Okay. The reason we do this is we actually know what sine squared plus cosine squared is. Okay. From the previous unit, we learned that sine squared plus cosine squared is 1. Okay. So I tried my best to fit it all on one page, but I didn't, so I'm going to have to go down here and finish the problem up here. I do want to show you real fast that what we said is when we made the unit circle, remember we said the radius of the unit circle is 1. Remember how we said this is xy, but this is also cosine sine? So cosine is x and sine is y. What kind of triangle do I have here? Yes, I have a right triangle. Hence, sine squared plus cosine squared equals 1 squared by Pythagorean Theorem. Okay, so that's why when we simplify this, that just makes that go away. So sine squared plus cosine squared is 1. All right, cool. So now we know that this is 1. Now I just showed you again that's 1. I can just rewrite this as b squared plus c squared minus 2bc cosine A is equal to A squared. And that, my friends, is the proof of the law of cosines. So let me blow it up here. Okay, so that's what it is. Okay, now some of you guys I noticed like to number steps. So I'm gonna go through here and just number these. Okay. And I'll be honest, I'm not a big proponent of numbering. I'm just doing that because hopefully it helps some of you guys. Because that I feel like that emphasizes memorization, and if you're logically flowing through it, you don't need to number because it's just flowing logically. Okay, so you'll find that if you practice this, trying to understand each step, It does not take long to be able to reproduce this, and a lot of y'all, I feel, already know this, judging on your last quiz. So hopefully this makes sense. Hopefully this helps. Give me some feedback. If you need me to re-explain something with this, I can do that. All right. See you guys in the next video.